Hi there, this is section 4.1, Solving Linear Systems by Graphing. Just to review, a linear system looks like this right here. It's when we have two equations with two unknowns. And the idea here is we want to find what values make the equations true. So let's talk about this first set of equations here. We have this 8x plus 6y equals 3580, and then x plus y equals 525. Now this is referencing a movie theater. It tells us x is the number of general admissions tickets and y is the number of senior tickets. And then it's asking us, what could these equations mean for the movie theater? And you may have already have thought this, but this first one could represent the cost per ticket. $8 for general admission, $6 for senior, and then we have a total amount of money. So this first one we can say is the cost per ticket and total amount. Now looking at the next one, we just have x plus y equals 525. Right, so we're taking the number of general plus senior and getting a total amount of tickets. So this represents the total amount of tickets that were sold, maybe. So now the next thing that we're talking about, it says, could the following be solutions to the system of equations? Meaning, could this, or this be a solution to this system? And then it says, well, what does a solution mean? So we have to talk about that first. A solution to an equation has to make the equation true, but a solution to the system would have to make both equations true. So a solution has to make both equations true. So the first one says, could the following be a solution? So what we want to do is keep in mind that when we have these values, this is our x, this is our y. So what we want to do is substitute those values in for x and y into the solution to see if they'll make it true. So we have to take 8 times 220 plus 6 times 305, and we want to know if that is equal to 3580. Now you want to make sure you use your calculator for this, that way you don't make any arithmetic errors. So 8 times 220 plus 6 times 305, and you'll find we get 3590. So we get 3590 when we evaluate the left-hand side, and we want it to be 3580. Those two values are not equal, so right away we know that this is not a solution. So what I would encourage you to do now is pause the video and work through the next two pair of points to see if either of those would be a solution. Keep in mind it has to make both equations true. When you find your answer, unpause the video and see if it's what I got. You will notice that the only ordered pair that makes both equations true is going to be the last one, 215, 310. Works in both, so it is a solution to the system. So now what we're going to be doing is finding that solution by graphing. So example 1, solve each system by graphing, identify the solution, and describe the graph of the system. So these two equations are set up nicely for us because they are already in slope-intercept form, meaning they're in the y equals mx plus b form. They're already solved for y. So we just need to go ahead and graph them. So the first one we're going to graph, I'm going to do it in blue just so we can keep them separated. So the first one is y equals negative 1/2 x minus 1. So this is where we have to start at negative 1, which would be right here, the y-intercept. And since the slope is negative 1/2, we have to go down 1 and to the right 2 places, and then plot the next point. Down 1 over 2 places, plot the next point. Then what you want to do is sketch your line that crosses through all three of those points. Now what we want to do is the same thing for the second equation. I'm going to use red for this one. Let's have you pause the video and sketch the line, and then unpause the video and we'll move forward. Now that we have our second line sketched, we want to look for the solution. We know the solution is going to be the point at which these two lines intersect. So you know I have marked the solution here. Now we have to find what that ordered pair is. So the x value of that is 1, 2, 3, 4. Well, 1, 2, 3, 4 is going to be 4. And then the y value is 1, 2, -3. That would be the solution. We can also call this the POI, the point of intersection, or the solution, which is 4, -3. The next thing we want to do, and we always want to do this, is check our answer. And we do that by the process that we did up above. You want to take your x and y value and substitute it into both equations to make sure it makes it true. So what I want you to do is pause the video and check your answer. We notice that this point makes both equations true, so we know it is the solution and we did not make any mistakes. Now the next thing it says describe the graph. So looking at the graph, we could say that this is a picture of two intersecting lines. So we want to say these as two intersecting lines. We're just describing what it looks like. Now, these other two things that we have here where it says define the system and define the equations, we will come back to that because we're going to talk about some key vocabulary words that we're going to put there. Okay, so we're going to work through two more problems very similar to what we just did. The main difference here in number 2 and number 3 is we have to solve these equations for y first, meaning we have to put them into slope-intercept form. What I'm going to do first is solve both of these for y and then solve both of these for y. And I want you to pause the video and do the same thing. When you're done doing that, unpause the video just to make sure you solve for y correctly, and then we'll move on to the graphing. So go ahead, solve for y, and then continue. So now we have all four of these equations solved for y. So now what I want you to do is pause the video again and graph all of these lines. Now, when we look at this one right here, we notice that we are missing the b, if you will, or the y-intercept. Keep in mind, if there isn't anything there, we can think of that as plus 0, meaning the origin would be our y-intercept. So go ahead and I want you to graph all four of these lines and unpause the video and check with mine. Now you can see what all of your graphs should look like, but now let's go through and find the solution and describe the graph of each one of these. So in example 2, the solution here. When we look at this, we know a solution is where these graphs cross, but these graphs do not cross at all. So we say this is no solution, meaning there is no ordered pair that would make both of these equations true. Describe the graph? Well, they are parallel lines. So if we see parallel lines, we know that there is not a solution. Again, we'll come back to the next two things. Now, in this last one, since we had the same exact equation here, we're coming out to getting the same exact line. So what that means is every single ordered pair would be a solution to both equations. So the solution, we're just going to say that there is an infinite number of solutions. We can't list them all here because there's an infinite amount. And describe the graph, we say they have the same graph. Now, whenever we have a solution that's an infinite number, we're not going to write infinite number of solutions. The way we're going to write that is what we call set builder notation. This is how you will be expected to answer when we find this situation. Set builder notation has curly brackets on it. And it starts by saying the point of all x's and y's, the ordered pair, such that, and then you're going to use one or the other of the originals. So x minus y equals 3. So what this is saying is all of the ordered pairs that make this equation true are going to be solutions of this. So this is how we would write the solution if there's an infinite number. Okay, next page. about some important vocabulary here. And this is where those last couple things come into play. We're going to define a system by either being consistent or inconsistent, and then we're going to define the equations in the system by either being independent or dependent. So a consistent system is going to be any system that has at least one solution. So consistent is going to be any system that has at least one solution. Whereas an inconsistent system is they have no point in common. Right, which means it would be parallel lines. Now, to define the equations, we have independent and dependent. Independent equations are neither equation is a multiple of the other. So neither equation is a multiple of the other. Whereas a dependent system, dependent equations is when one equation can be obtained by multiplying both sides of the other by a constant. So to write out a dependent, and I'll show you what this means here in a second. So we say when one equation can be obtained by multiplying both sides of another by a constant. Again, that's when one equation can be obtained by multiplying both sides of another by a constant. So we're actually going to kind of skip over example 4 for now, and let's go to example 5, and let's look at 5c for an infinite number of solutions. This is where we're going to see that dependent. So what example 5 says, for each of the following conditions, write a system of equations. So for 5c, if I write the equation, we'll just say 2x minus 3y equals 5. Now, if I multiply both sides of that equation by a constant, I'm going to create a dependent equation. So if I take each of these terms here, meaning the 2x, the negative 3y, and the 5, let's say we multiply everything there by a 2. 2 times 2 is 4x. 2 times a negative 3 is negative 6y. 2 times 5 is 10. This would be an example of dependent equations because we can multiply everything here by the same constant to build this one. Now, while we're on number 5, let's work through this. It says, write something that has no solution. Well, we know no solution would be an inconsistent system because there's no point in common, which means we have to have parallel lines. Now, recall from what you know previously, parallel lines are when we have the same slope but different y-intercept. So go ahead and write a system of equations that has the same slope but different y-intercepts. You can see that I just wrote y equals 3/4 x minus 1 and y equals 3/4 x plus 2. It doesn't matter what you write as long as your slopes are the same and your y-intercepts are different. Now, for the next one, for each of the following conditions, write the system of equation such that negative 3/4 is a solution. Meaning, what can we do with these two values to get an answer? So for example, the first one, if we just take x plus y, meaning if we add those two numbers together, negative 3 plus 4, what do we get? Right, you get a positive 1. So that would be one equation. Now what if we wanted to write x minus y? What would we write as a constant on the right if we set up x minus y? Right, we'd get a negative 7. Negative 3 minus 4 would be negative 7. So there we created systems given certain parameters. Now, example 4, the last example that we have here. Solve graphically with a calculator. Where appropriate, round to the nearest hundredth, provide a sketch of the graph to support your answer. Now, we're not going to be graphing these by hand, which is why it tells us to use a calculator because of the numbers that we are being given. So what you're going to do first is solve both of these equations for y, and then we're going to supplement using our calculator. So go ahead and solve them both for y to start. Okay, so once we solve both of these for x, what we want to do then is type them into our calculator. So if we press the y equals button in the top left-hand corner, we type y1 and y2. It doesn't matter which one you put these in. And then we press the graph button. Now at first, if your window's set to the normal window, you won't be able to see them. But if you press zoom 0, which is zoom fit, it'll zoom out for you. And you will see that this point right here is our intersection point. However, we can't identify what that point is exactly by looking at the graph, so we have to have our calculator tell us. And I wrote the steps out here. To find the point of intersection, we want to hit second and then trace, which is up at the top. It's the F4 button. It also says calculate. And then you're going to use option 5, which is intersect. And then you're going to press enter 3 times. 1, 2, 3. And it tells you the intersection point. And it tells us to round to the nearest hundredth. So we can round this off at negative 6.37. And our y value is negative 18.77. So this would be our solution to this problem. The last thing we need to go over in this video is going back to the 3 examples we did before and define the systems and define the equation. I just put all of mine onto this page just so I don't have to keep flipping back. So for the first graph, this first one's example 1. We said that the solution is 4 negative thirds. We have 2 intersecting lines. Now we want to define the system. Remember, to define a system, it's either consistent or inconsistent. Consistent is any system that has at least one solution. So in example 1, we see that there is a solution, so this is going to be consistent. While we're talking about defining the system, the second one, we have parallel lines. And if they're parallel lines, they do not have at least one, so therefore this would be inconsistent. And the last one, right, there is at least one, so this would also be consistent. So the only inconsistent system would be parallel lines. Now we want to talk about defining the equations. We said that they're either independent or they are going to be dependent. Remember, independent means neither equation is a multiple of the other. Whereas dependent, it's when one equation can be obtained by multiplying a constant. So dependent equations essentially mean that you're going to be forming the same line because they are multiples of each other. So in the first one, these would be an independent equations because they are 2 totally different lines. They are separate. The second one, they would also be independent because they are 2 different lines. But in the third one, they are the same exact line. So they would be dependent because they depend on one another. You must know these vocab words of consistent, inconsistent, independent, dependent. I recommend making flashcards if you need the extra help with those. Okay, I know this was a little bit longer of a video. 4.1 is a little bit longer of a section. We take 2 days to cover it in class. Please reach out if you have any questions at all, and good luck on the homework.